Yeah, hey, let's get started. I've graded most of your assignments. I think I'm only like one homework assignment behind. One thing I noticed that some of you are not working with a partner, so you lost points with that. You need to do that. I promise you, if you're just doing this without a partner, you're not getting something. You're not understanding one part of cryptography. And so you're going to have trouble down the line. Okay, so make sure you're working with a partner and doing that as it's going to get much more complicated. You're going to have so many keys that, and you need to know what belongs to who. So, what belongs to Bob, what belongs to Alice, etc. That's why I'm asking you to work with a partner. Okay, so make sure you do that. But yeah, I've graded most of your assignments except I think the last one. I can't remember what it was. I think it's the hash OpenSSL one. And then I haven't started grading your exams, but you had the exam on Tuesday, right? So I'll be working on that over the weekend. And then yeah, so we pretty much have completed like the first third of the course, which was really symmetric block ciphers types of, encryption. We focus mostly on the confidentiality. It's not like we're done with that, right? That's a part of SSL, the part that provides the confidentiality efficiently. So we will come back to that, but as far as the algorithms are concerned, we're kind of just wrapping that up today. So if you remember, I think the last time we met, we were working on CBC XOR, right? And I think we haven't finished it, unless you guys have finished it on your own. All right, so that will be due a week from today. Probably we'll probably finish that one, I assume, today during the first half of class, and then we're done with that part. So then we'll start second, third of the class today because it's a lab day. We'll just start looking at some code and things like that, and then I'll do a formal lecture on Tuesday. So now the topic that we are starting with in cryptography is asymmetric encryption. Okay. So we'll start looking at that. Um, and that's basically, if you're familiar with the term RSA, right? There's something else called elliptic curves. And so those are the two big like algorithms out there. So we'll certainly spend a lot of time on RSA, and then elliptic curves come in a little bit because blockchain and cryptocurrency kind of uses that a little bit. So we'll touch on those ideas a little bit. But yeah, so we'll start with RSA right now. Probably today I'll just do like a very, very simple toy kind of a Python example of how RSA works, start diving deep into it. I do provide one script that is like a full implementation of RSA from scratch. Okay, so that will be pretty interesting. It's got a lot of very amazing algorithms probably, you know. And so we'll discuss that. But anyway, yeah, that's the plan for today. I'll probably make two videos, one of just wrapping up CBC, and then I'll make one as time permits of whatever RSA that we can cover today. Okay. So that should be the second third of the class, and wrapping up towards that, we get to completing what is SSL. And then the last third of the class is just like applications, where is in cryptography applied and so on, things like that. Does that make sense? Any questions before we get started? All right, I'm not hearing any questions. So, we're just going to start with the virtual machine, and you guys can help me out just to see where we were in the code. I believe we were almost there, but we were just kind of debugging some of the problems with the CBC algorithm. So we should be recording right now, I believe, and we need to start the virtual machine. Okay. Okay, start. Okay, there it is. Right. So let's log in. Okay. Right, so we have the terminal here. Go ahead and begin. Let's navigate into the desktop. And I'll give you a reading assignment also, just to keep with current events. I noticed recently, this is something that I noticed this week actually, it's either Google or Microsoft, they updated one of their encryption algorithms to be one of the what they call now the quantum ready algorithms. So I'm going to give that this is like state of the art at this point, right? So I'm going to give you guys a little reading assignment, just just to kind of get a feel for what's going on. But apparently they're starting to implement new algorithms. So this is actually interesting, right? So I've been teaching this class for 12 years or so. I never had to tell students, hey, here's a new thing in cryptography. You know what I mean? It's always been like the things that were invented in the 70s, early 80s. It hasn't changed, right? It was just pretty solid, but now we're in a new world where we have to look at actually new algorithms that are coming out all the time for cryptography because they have to be quantum ready. And what happens is somebody says, hey, we did it, we're done, and then they make it available, and then 6 months later, somebody at Stanford or somewhere else breaks it, and it's not good, right? So, but yeah, so I don't know if it's going to be like this, if these are the final algorithms that we're going to be using for the next 15 years or so, but certainly you're going to have to start reading as this is a changing area. All right, so I'll provide that on Brightspace a little later. All right, so let's go ahead and go into our folder. So this is the ITS 350. Okay. Oops. 4. So we want to find the script that we were using last week, last Thursday. So that should be probably in block ciphers. Right? Is in where? Oh, that's right, because I copied it, right, from XOR hash. You're right. So XOR hash. Right. All right. Yeah, there it is. So yeah, I did call it CBC XOR 3, just in case it was a little bit different from the CBC XOR 2 that I had on my GitHub. And then, that way I can just upload it there. All right, but I think so far it's been the same algorithm. We did the pickle part, so that's good. That way you guys can send the data to your partner when you implement this algorithm. Should be the same as before. I'm going to make this homework assignment. You have to get this code running, show evidence, screenshots that it ran, and then work with a partner and just use it, right, to encrypt and decrypt and make sure that you're doing that correctly. Again, the key at this point can't be exchanged securely. All right, so let's can't remember if it was running, so let's just take a look at it. CBC XOR 3, right? So I'm using Nano, so I'll just do a quick, all right, so this actually is CBC. Perfect. And oops. Right, yeah, so that's basically what it is. I've already covered DES, the data encryption standard. We covered that as an algorithm in lecture, but I'm not going to make it a requirement for implementation, as that could be much more elaborate. This is hard enough, right? So we're going to look at just the CBC, which remember, it's a mode of operation for block ciphers. So we got gen key, we've got padding, that seems to be function that we have available, although I think we were doing the padding inside here in this. So break message, I remember that was working fine. That's just a hash function. We're not using that here. Then we have two encrypt operations because you remember in the diagram, we are actually doing two XOR operations, one with the initialization vector and one with the key. So that's encrypt 1 and encrypt 2. So that should be going. That's the forward pass, right? And then we have to obviously reverse that to get our decrypted message. The great thing about this is that we'll know if our algorithm works, right? Because we should get the message back. All right. Remember that when you work with your partner, you're going to have to send them the key here. So my suggestion, just save that key with pickle. Does that make sense? Yeah. And then load it up into memory, and that should be pretty straightforward then, because it's going to be binary. All right, so then I think we're encrypt message. So this is the actual function that puts together the two ideas, the two XOR operations. So that's there. Then I believe this is where we were. Decrypt, we were still trying to debug some issues with the code. And that's probably that's the hardest part of this, right? So to kind of make sure that we're doing this correctly in reverse. Okay, so decrypt 1, decrypt 2. So I think this wasn't fully functional yet. And then this is the function that brings those two together. Then, okay, then we have a plain text CBC with some message. We read it in, we print it. We're using blocks of size 8. Break the message. Our key and our IV are generated. So as I was saying, you're going to have to send this key and this IV probably to your partner. Although I'm not going to write the code for this, you should be able to write it on your own by just using pickle as the example I provided. Does that make sense? All right, good. So here we go. We encrypt the message and then we print the cipher list, and it's basically just I think a list of bytes, and that's what you can exchange that. That's perfectly fine to make your lives easier. Really doesn't matter. It's encrypted already. Here's the pickle, right? So I showed you how to do a pickle dump. So here you're sending the cipher list. You'll do this pretty much the exact same thing with the key and the IV, right? And then I showed you how to read it in, all right? So, and we tested this, that it works. So once I read it, pickle load, I load it into from pickle cipher list, right? So this is basically like when you get an email, from your classmate, you will, whatever that file that you're, put the name of your classmate there, Mary Sue, right? So, and read it in so that you know that you're reading the correct thing. As I said, this is where it starts to get complicated. Like when you start to wonder, right, whose key, whose file do I use? So, and believe me, once we start doing RSA, then you'll have, RSA is more complicated than this, and you'll have still this, right? So you'll have the symmetric part, the asymmetric part, and RSA has more files. So it's not that it's super difficult, but it's just more things to account for, So put the name, I would say, oh, this came from Alice, this is Bob, this, and that way you will orient yourself a little bit better. All right, so then we print the pickle file, right? And then obviously that file from pickle cipher list is what we provide to decrypt cipher, right? With the key and the initialization vector. And, we need the initialization vector probably in the last step. So we'll take a look at that. And then here I'm just printing it. And that's it. That was the code. Everything else was just, if you remember, I gave you these little functions for you to be able to change something into hexadecimal or binary. They're basically formatting things for you to view things a little bit better. All right, any questions about any of this? All right, so let's see where we are. Let's run it. So you can see that, let me see what the message was originally. Cat plain. All right, so yeah, so I had 3 sentences in there. This is a very secret message, and the secret code is 1, 2, 3, 4, and then I wrote G, DG, VXV. So we need to get that back. Okay, all right. So let's run the code and see where it breaks. So I'm going to do Python 3. Okay, so it is breaking. All right. String object cannot be interpreted as an integer. Decrypt cipher. So in decrypt 2, we're having an issue. Return byte array. All right, so this is what we're going to try to solve now. So if you guys want to help out, that's great. See issues. All right, so we are basically, I'm just going to try to debug it a little bit, see what's going on. Decrypt 1, print, cipher key. Right, all right, so I was doing this, and then let's think about the logic, right? So we read, how do we read this? We provide the encrypted message. We have blocks. And then how do we decrypt these blocks? How do we reverse it, right? That's the key thing that we need to think about, right? In this idea, we need to figure out how to reverse the logic. So I'm gonna open up that Wikipedia CBC encryption, right? And we're gonna think about how to reverse it. I think it was here somewhere. ECB is this one. CBC, here we are. So, okay. Ciphertext comes in. Oh, this is the decryption part? Okay. Let's do this one then. Yeah. Plain text. Okay. All right. We have plain in the forward path. In the forward pass, we get plain text, the initialization vector. We have a list of blocks, right? We have a list of blocks, and I think that list of blocks is what we're saving to the pickle. So then we've read it back. So we would get a plain text initialization vector that gives us a vector. Then we XOR that with the key and we get ciphertext. And then we repeat that for all. So basically we should be sending a list of these cipher blocks, right? Now we have to obtain these plain text messages in reverse. So we've been doing this trick quite a bit all semester, right? So the idea of XORing back. So we have a list. Now, one thing that you might think intuitively is, okay, I have to start from the end and work my way back, right? Or you can actually think that there might be a way that you can actually still go from the beginning and decrypt it, right? So we just have to think about that logic. Let's grab one in the middle. So if I have this one, right? And what do I need really to decrypt it to get the plain text message? I need the key. That's perfectly doable because I do have the key, right? The key is always the same thing. Do you agree that it's always same key? So if I have the ciphertext that, let's say we have ciphertext 1, 2, 3, 4, 5 until n. So we're on currently 5. I equal 5. So what do I need? I grab ciphertext 5 and I XOR it with key. That's easy to do, right? We can do a decrypt function that does that. And that produces imagine the decryption vector that goes here. No issue. Decrypt 2, the next function should take the result of this one and XOR it with what? To get this plain text. What do you guys think?
What's the question?
Okay. Right. So very important, right? So so we're in decrypting. We're in the decrypt. And I have a list of cipher. So you might think, well, if we went in this direction, then now we have to kind of like reverse it, right? And work our way from I minus 1, minus 2. But actually, that may not be necessary. We can still do a forward pass. So let's just think about it, right? So we're decrypting. We know there's two XOR operations, decrypt 1 and decrypt 2. So let's say that I have ciphers 1, 2, 3, 4, 5 all the way to N, just because I grab randomly index 5, cipher 5. So that's this one, cipher 5. What am I going to do in the steps to get this plain text, which is what I need? So I grab cipher 5 and I XOR it with key. That's straightforward because it's always the same key. Do you agree? So that gives us this block here, the one in, the output of that. The next step, that block should go to decrypt 2. And then what do? We take that block and XOR it with something to get this plain text. And boom, we've got that plain text, right? So what is that? What do we need here? The one before it, very good. So if we know that if we're iterating in a forward pass, in the for loop for I in range 12, let's say we're on 5, then what's that index? It's just going to be 5 minus 1 or I minus 1. Do you guys see that? So then all I need here is if I'm iterating and this is I equal 5, then that's I equal 5 XOR key, done. The result of that gets XORed with I minus 1. Do you see that, guys? So that's it. So all we need to do is grab the previous one and we're good. And we need to have so if we're now that's clear, and that should be the same for everything between 2 and n minus 1. Now let's just look at the extremes, like the first one and the last one, because that's going to give us probably an issue. So let's look at the last one. In the last one, we take ciphertext n, XOR key, boom. We get the temporary vector, and then that temporary vector gets XORed with n minus 1. And we should have plain text. Do you guys agree? Mm-hmm. Okay, perfect. So that's easy too. That works in our logic. So then now let's look at the first one. Ciphertext 0, or what? It's going to be 0, like I0, right? The first item in the list. So I take ciphertext 0, XOR it with key, easy, get the temp, and then now what do I need to do? That temp vector needs to be XORed with what? IV. The IV. Perfect. And then we should get the first plain text. That's it. That should be the logic. We don't have to reverse it. We should be able to go in a forward pass. And just like an if statement maybe that says it for the first one, actually use the IV. For the other ones, use the previous vector. Do you guys see that? All right. So let's go ahead and try to code that. And then let's add that logic, and then we'll check for any errors or anything like that. We need to go. Perfect. All right. So decrypt 1 only needs the key. So I have all these print statements. Let's get rid of that for now. Can edit that. I'll let you guys play with it a little bit. All right, so this one is the first pass. All we need is the key. So really, well, actually, let's look at the logic here. So we do list of decrypted blocks. Then for I in range, length of list cipher. So we're going to assume that there's 12 blocks in there, right? And we grab a block, the first block. First block goes in here, and we XOR it with key. There it is. Perfect. And that should give us 10. So decrypt 1 should be working, I think. So then what happens when we send that to the function is now the function receives that particular block. It really doesn't care. And the key, and as long as they're the same size, it's just going to perform the XOR operation. Because they're both byte arrays, it should just be something like cipher key for I in range length of cipher. Yeah. And yeah, that should be it. Does that make sense? All right, so that should give us temp block. So what I'm going to do now is I'm going to assume that that is correct, okay? And I want to see if this gives me an error, okay? I want to see if this gives me an error. So it's what comes out of temp. So what I'm going to do is I'm going to halt the program, but I'm going to say here print temp. I just want to see what temp is, if it looks like a byte array, basically. you know. Okay, and then I'm gonna just print a little message, uh, you know, halting the program. Okay, and I'm gonna stop it with an input, just so I know that I get no errors actually at this point in the script. Any questions? Okay, so Control X, Y, enter, and clear there. All right, halting the program, so there's no error. I do see a byte array, so I'm just going to assume that that's correct. Okay, does that make sense so far? Now this is going to be the input to the next operation, the next XOR, which in here actually this is. So it did decrypt it, right? That seems to be the original message. Okay, yeah, perfect. Give me a sec. So you see this is A, this is. So we are decrypting that block. The question now is that decrypt 2 should take that and XOR it with the IV. And it says here, string object cannot be interpreted as an integer. So is that what you, okay. All right, so let's go back to the code, right? So I'm gonna, first of all, okay, we need to scroll down. Oh, here. Right, so I'm gonna just comment out these and then you can let me know what the error. Remove these. All right, so then temp goes into decrypt 2. So what do you think is the error?
So it looks like it was taking res as a string. Looking into what res is in decrypt 2, it's reverting the ASCII character, it's turning the ASCII characters back into its like normal.
Mhm.
And you know what I mean.
Mhm.
So taking out CHR might work.
In decrypt 2,
Yes.
but then it's gonna give us numbers, right? Don't we need the
String, but that's the main error.
where? Hold on. So decrypt 2 seems to have worked though, because it gave me this is, so it decrypted
Decrypt 1.
that one. Yeah, that one.
Yeah.
Okay, so but you're saying, where do you think the error is?
Where it's,
Here?
yeah, because it's taking the CHR and then it's XORing cipher, each cipher in the key. But if it's going to XOR the ASCII characters like A, B, blah, 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 it's going to take it as a string.
But I think so, if I understand correctly, so think about the logic of this list comprehension. So for I in range, before it does the CHR, is XORing cipher I and key I. So it is XORing them at the byte array level.
That's before?
Yeah, that's before. Then the result of that becomes the input to CHR. Do you see what I'm saying? So look at it. This is why I add these big spaces in between. So the parenthesis starts here and it ends here, right? So usually then it will do this part, that part first. And the result of that then becomes the input to CHR. So in that case, it should be doing the string, the ASCII conversion after the byte array XOR.
Okay.
Got it? Yeah. So, and I think also it was working because we were able to see this is. So it did actually take that first cipher and gave us back the plain text. Any questions, guys? Comments? Nope. All right. Great. So, all right. So then what's the problem then? All right. So here it gave us the first one. It prints it byte array res decrypt 2. Why am I converting it to a byte array? That doesn't make sense, right? Guys, doesn't make sense. Yeah, it doesn't make sense, right? So I think we should actually get rid of that byte array and just return res. Okay. Okay. So then explain what comes out of decrypt 2 should be added into the list of decrypted blocks, and then we should just print it out. Make sense? Any questions so far? Now, if I look at this lot, okay, so that let's assume that for now that is kind of okay. So then let's go back to decrypt 2. One error that I think is present in decrypt 2 is that we are, or actually in not in decrypt 2, that is present in decrypt cipher is here. It's like somewhere around here. I do 4i in range. So I'm grabbing a list of 12 blocks, right? Blocks of size 8. So I grab the first block, the second block. But I should be, and I did decrypt with the IV the first time, which is correct, actually, right? The IV is the first. So if you look here, it takes the first, we're in the list, right? List of 12, right? So I is equal to 0. We grab the first block, and that temp block gets XORed with IV. That should be correct. What might be incorrect is that the next time around, right? If we go back to the graph over here, so we did this. We took this guy, XOR with this, gave us temp, XOR with IV, and we got that, right? But what about in the second one? We take ciphertext, key, temp, XORed with the previous ciphertext, not IV, right? So then that should be it, right? Hopefully if, we can solve it then. So I think what I'm going to try next is I'm just going to say, probably, since this is the first time, it'll do the IV by default. I don't even need an if statement, I think. Yeah, so then all I need to do is say, right after this decryption, then definitely change that IV to be something else, which in this case would be list. It would be, actually, it would be this one, list cipher I, and it'll just stay in memory. Will it stay in memory? Yeah, because this is this is a variable defined here in the arguments of the function, so it's there, right? So this should work. All right, so then all I have to do is give it list cipher. I think that does it. Do you guys get it? So we have a list. Okay, so let me repeat. So we have a list, right, of cipher blocks. We give it IV, key, list cipher. So this is the IV. We iterate through it from 0 to 12. Let's say I'm using this arbitrary number 12. First time around, I grab cipher 0. I grab the key, no problem there. Then that produces temp, and I XORed with the IV, which I have, no problem. But that's the only time when I is equal to 0 that I need IV. After that, it needs to become the previous cipher, right? And so all I have to do is give it IV equal list cipher I, because it's going to be saved there for the next iteration. Do you see that? So now it's going to go back into the for loop as I equal 1. IV is now list cipher I, which is the previous cipher block. And when I do this part here, this XOR operation, IV is no longer IV. It is just the previous cipher I.
So IV is just the variable.
Yeah, I'm using, yeah, I could have been more like, I could have created another variable or something, but I'm just being lazy with code and I just don't want to have that many lines of code. So I only use IV for the first time. And then after that, I replace it with the previous cipher every time so that, when we do cipher, let's say the, 0, 1, 2, let's say I grab the second cipher block, I save it in IV for the next iteration. Does that make sense, guys? Any questions? Well, let's see if it works, first of all, right? So let's go there. And we were getting an error. Let's see what that error, I think logic-wise, this should be correct. And you can corroborate with the function there. That's on GitHub also. Control X. All right. But let's see if we still have an error in here. There was a string error. Python 3. No, I guess that it was that byte array, maybe. What?
No, it was looks.
I know it looks weird, but let's look at the original message. So it should end with GDG F S V XV, yeah. And the padding. That the padding is these three padding spaces over here. Guys, do you agree that this works fully now? Do you have any questions? No questions? Everything makes sense? All right, seems like there's no questions. All right, so you guys have completed we've completed basically the mode of operation CBC for block ciphers in symmetric encryption. Okay. So what I'm going to do now is I'm going to create the homework link for you guys to submit this a week from today. Same idea. Make sure that you provide enough evidence that this code works, and then create a message, 4 or 5 lines of text, and work with a partner. You now need to achieve confidentiality of a message, right? So before you achieve integrity by doing a hash, right? I've graded that homework already. Now you need to, this is a secret message. The code is something, send it, and they need to decrypt it on the other end. And you need to exchange the key basically insecurely this time. Got it? Any questions? All right, so I will create the assignment link. And then, as I said, we'll start RSA, basically, totally new sequence of topics. But that concludes the first third of the semester. All right, so let's take a look. All right, so I don't need this anymore. Let's go back to 350 here. Content. We are around here. This is RSA, SAM1. So it should be this one, I think. Feistel network, crypto code. Yeah, so Word document, open it. Right, so complete the following problems. It's done in class. Use the instructor provided XOR code to implement the scheme, in this case CBC, that allows you to encrypt and decrypt some data using symmetric encryption principle. Okay. The key aspect is that you should generate several blocks from the input and you should encrypt with CBC. Implement the Python code and show your results with screenshots and comments. You need to run it without errors and show evidence that it works. You need to do this. I already even wrote that part. You need to do this with a partner and send the encrypted message for your partner to decrypt. Reading and writing to and from files may be required for this problem. Submit a report showing your work and results. Remember, you need to create a Word document or PDF with screenshots showing enough evidence that you've accomplished these tasks. You know how to read and write files now with Pickle. It'll make your life easier because you don't have, you can just take a screenshot of a list of bytes or whatever and save it. Any questions? So I'll just create a link and it'll say complete the attached Word document. That's basically it. All right, so hopefully that's clear enough as a homework assignment. And then it'll be due a week from today. Okay, here we are. So assignment. All right. Let's see. Oh. It'll be due on the 3rd, October 3rd. So that's done. So it'll open today and it'll stay open until 6. Okay. All right. Link is created so that your homework assignment is assigned. All right. So great. So that, as I said, concludes the first third of the semester, symmetric encryption. None of these ideas are going to go away by any means. This class really built on top of what it's seen before, previous primitives, but we are now going to address a different problem, which is the key exchange problem. Okay. So again, RSA is not for encrypting the message. Okay. RSA is not for encrypting, you know, a Netflix movie or something like that. It's much slower. And it's not actually meant for really big things. So it's meant for smaller things, right? And eventually one of the labs will be a performance test where we're going to compare like, you know, RSA to, you know, something like this. And we're going to see that this should be faster. So, but also, you know, during the last 6 weeks, we've been asking this question, how do I exchange the key correctly, right? And that's what our new asymmetric encryption algorithms are for. It's not just RSA. There's another technique called elliptic curves. It's a little bit more complex. We'll cover that as well. There's also Diffie-Hellman. So these are the 3 big techniques out there for doing this. So mainly RSA is the most popular traditionally, and it's where I'm going to spend the most time. And then I will cover the other ones more briefly. All right, so let's go then. I'm going to, so that this is done. So let me just click on this. Link is there. Okay. I'm going to close that. So I said I was going to end this video. So end it. I'm going to start a new one so they're not